Yeah.
That's where we need to start thinking differently about computing power.
Okay.
And the Apex highlights this perfectly. It contrasts two approaches, vertical and horizontal scaling.
Okay.
Vertical scaling is what you were just talking about, getting a bigger, more powerful computer, but there are limitations to how far that can take us.
Yeah, my bank account is already crying at the thought of constantly upgrading my hardware.
It gets expensive.
So what's the alternative?
That's where horizontal scaling comes in.
Okay.
Instead of one supercomputer, we create a cluster of interconnected machines, each handling a piece of the data.
Okay.
Think about it like our brains. We don't have one giant neuron doing all the thinking. We have billions working together in parallel.
Right.
That's the power of horizontal scaling.
So it's all about teamwork, even for computers.
Yeah.
But how do we actually organize all these machines to work together effectively? I can barely get my printer to talk to my laptop.
Well, yeah.
It's like, come on.
There are two main approaches, and they're both pretty fascinating.
Okay.
First, we have cluster computing. This is where the computers are similar, located close together and highly interconnected. Think about those massive data centers Google uses. That's cluster computing in action. Then there's grid computing, which is more like a global collaboration. Different computers spread out geographically with various resources, all contributing to a common goal. The Apex actually gives a great example of this, the SETI at Home project, where millions of people donated their computers' idle time to analyze signals from space. That's grid computing at its finest.
So cluster computing is like a well-oiled machine, while grid computing is more like a grassroots movement, harnessing the power of the crowd.
That's a great way to put it.
I like that.
And speaking of well-oiled machines, let's talk about Hadoop, which has become synonymous with big data solutions.
Hadoop. I've heard that name thrown around, but it always sounded a bit intimidating. Can you break it down for us? What is it and why should we care?
Absolutely. Imagine Hadoop as a 4-story building, each floor with a specific job.
Okay.
At the bottom, we have the distributed storage layer, which is HDFS, the Hadoop Distributed File System.
Okay.
Think of this as the foundation of the building, ensuring our data is safely stored and readily accessible.
So it's like the foundation, making sure our data is secure and accessible. That's critical, right? Especially when we're talking about these massive data sets.
Absolutely crucial.
What's on the next floor? What's on the next floor up?
Above that is the Resource Manager layer managed by Yarn, which stands for Yet Another Resource Negotiator.
Yet another resource negotiator.
Don't let the funny name fool you. This is a crucial part of the system. Think of Yarn as the foreman on a construction site, efficiently assigning workers, our computers, to different tasks.
Okay, so we've got the storage and the management taken care of, but how does the actual data processing happen? Like, where does the work get done?
That's where the third floor comes in. The processing framework layer, which uses the MapReduce programming model.
Oh, yeah, MapReduce.
MapReduce is like a highly efficient production line. It breaks down complex tasks into smaller, manageable chunks and processes those chunks in parallel across multiple machines. The mapper divides the data and performs the initial processing, kind of like prepping the ingredients. Then, the reducer aggregates the results, putting it all together to get the final dish, so to speak.
So it's like a well-coordinated dance of data happening across all these different machines. What's happening on the top floor? What's happening on the top floor?
That's where we find the application support layer, which provides the tools we need to actually work with the data. Hive, Pig, Mahout, these are just a few examples of the many applications built on top of Hadoop, each specialized for specific tasks. But the key takeaway is that Hadoop makes it possible to extract insights from data that would otherwise be completely overwhelming.
So Hadoop is like the ultimate data organizer, making sense of the chaos and giving us the tools to find those valuable nuggets of information. That's pretty impressive. It's like it's doing all the heavy lifting for us.
It does a lot of the heavy lifting.
Yeah.
And while Hadoop is great for handling these huge data sets, sometimes we need even more flexibility, something that can adapt to constantly evolving data structures. That's where the world of NoSQL databases